Today we're going to be going over infinite limits. So we're basically going to be looking at limits whose value equals to plus or positive or negative infinity. And we'll just go over what it means for a limit to have an infinite value. So say the limit of x as x approaches a of f of x is equal to infinity. So basically, we're going to be looking at a lot of problems that follow this similar format of a function and, well, of a limit of a function as x approaches a, and the infinite values and what we could be doing when it comes to graphing and finding said limits for these infinite values. So we'll be going over that today. We're going to be going over some practice problems as well. So yeah. All right, so let's go over this first. So we'll say the limit as x approaches a of f of x equals to infinity when we can make f of x arbitrarily large for all x close to a without equaling a, basically. Um, And we'll say the limit of f of x as x approaches a is equal to negative infinity when we can make f of x arbitrarily large and negative for all x close to x equals a from both sides equaling without x actually equaling a. So basically that means if we can make f of x big and negative for all x close to a on both sides, then we basically can denote it as negative infinity. So let's show an example. Let's go over a very basic example to kind of understand more so what this means. We'll say we're given a limit as x approaches 0 of 1 over x. There are multiple ways to solve these, well, this limit specifically. And also, let's say, well, I'll just write it out for now, but later on I'll just get a little bit lazy and not write them out. But basically, we're going to find these three values. We're always going to try to find these values first, for our examples at least. I'm only going to write out this later on, but basically we're going to be going over these kinds of problems, finding the limits of these three, I guess, well, they're not separate functions, but I guess basically for the same function, we're going to be finding the general limit, the left side of the function, or the left side of the function, the limit for that, and the right side as well, as we could see from our positive and negative right here. I also have a video on one-sided limits if you want to check it out. We go over what that means as well. So, but let's just keep up, let's say, the limit for this, right? And let's create a table in order to illustrate our I guess what it means for a value to be infinity. So let's start with the left-hand side, or negative. So say x in our f of x, and this x is going to be increasingly closer to a, or in this case 0, more so like in negative values. So basically it's going to be negative 0.1 and negative 0.01, negative 0.001, negative 0.0001, so on and so forth. And as x approaches a from the left-hand side, and just to clarify, usually we can kind of assume that our left-handed side is going to be, negative. Positive will be our right-handed side because that's on the x, I guess, axis. But anyways, as x approaches 0 from the left side of this function, we notice something. We see that, well, for this, it'll be negative 10, right? And again, since it, I guess, increased by 1 decimal, we increase ours by 1 decimal, and we continue doing so as x gets closer to 0. And as we can see here, it inevitably ends up being negative infinity. As we can see here, as x approaches 0 from the left-hand side, the function 1 over x becomes negative infinity. Alright, so what about the right-hand side? You may be asking, I'm sure, out loud, alone. We'll make another table. We could include these in one table, but I mean, I don't really have a lot of room to be working with, and I kind of write big. So say x in our function 1 over x, but this time it's going to be positive. So 0.1, 0.01, 0.001, 0.0001. So it's basically the same thing, but except for negative, it's just positive, as we can see here, for 1 over x. And we basically, well, we basically know that we could just flip it for this function specifically. So for 0.1 it's 10, for 0.01 it's 100. We increase by another 0 once we see another decimal being, I guess, added. So, but as we can see here, the function 1 over x, as x approaches 0, is infinity now. But before, when it was approaching from the left-handed side, it was negative infinity. And that might be confusing because you might say, wait, what about the general limit then? Since there are different limits, technically, what will the general limit be? And we will go over that right now, actually. Let's write out a graph. Or draw out a graph, because you kind of draw it out more than... Alright, whatever. Let's see it. And if you've taken Calc 1 before, or you understand pre-calculus pretty well, you already understand that for this function specifically 1 over x, it's just going to look like this. It's basically going to be asymptotic at x equals 0, as we can see here. But basically, we can see how they are essentially two one-sided limits right here. There's one side here. This is as x approaches 0 from the left side, and x approaches 0 from the right side. Basically, due to the fact that there are two limits, or at least two quote-unquote values, infinity, negative infinity, that the function is approaching as x approaches 0, we do not have a general limit. So basically we say it does not exist, or DNE for short. So basically, due to the fact that x approaches 0, it ultimately depends on which way it is coming from in order to determine the limit. So it really just ultimately depends on whether or not our exponent next to our a is negative or positive, whether or not it is the left-hand side of the limit or the right-hand side, because limits like these have two one-sided limits instead of one general one. Let's just go ahead and clear this. and we'll work on a few more practice problems to truly understand, and also keep note the asymptote at x equals a. Maybe that means something, you know? So we'll go over that in a bit. So first, let's go over the, we'll say the right-hand limit first. So for the right-handed limit, we would basically write it as, and right-handed limit just being this limit right here, just with the plus. So basically, with the right-handed limit, we would say x is greater than -2 from the right-handed side. We would then turn that into x plus 2 is greater than 0. And we already know why we write it down as x is greater than -2 is because it's from the right-hand side and it has to be positive. Just think of it as if it's greater than, it's positive because, well, it has to be greater than the actual value. And if it's from the left-hand side or negative, that means it's going to be less than. So just associate negative with less than and positive with greater than, because that's basically what we saw from the table before. So we can turn this into x plus 2 is greater than 0. And basically, as x gets closer to -2, then x plus 2 will be getting closer to 0 while staying positive as noted before. It will then result in negative infinity. So it could just be equal to negative infinity right here. And for our left-handed side, which is our negative, we'll say x is less than -2, which then we could turn into x plus 2 is less than 0, because we could just add 2 from each side. And basically, x plus 2 will get closer to 0 as x gets closer to -2. In this case, we'll have a negative constant divided by an increasing small negative number, making it infinity. Because the limits are not the same of the left hand and the right hand side, that means the general limit does not exist. But let's do a graph for this function specifically. Whoops. And just for a reminder, we'll put it in the top right corner. Limit as x approaches -2 of -4 over x plus 2. So because they're not the same, we're going to see a very similar situation happen right here. So the left-hand side of the limit is going to look like this, because it is asymptotic. And we're gonna outline this like that. And our right side limit is going to be negative infinity, but it's basically going to come from here. So as we can see, a very similar situation happens here, where as x approaches -2, it basically has two values. It has infinity and negative infinity. And due to that, the general limit of -4 over x plus 2 does not exist. Because as we clarified before, the left side of the limit has to equal to the right side, or else we have two one-sided limits. So basically, like remember before when I was talking about the asymptotic lines, and the asymptote of x equals 0, we see the left side of the limit is basically has the asymptote as at x equals 0, and so does the right side of the limit. So there's a purpose for this, and let's just go over that real quickly. One second, let me just erase all this. So basically, the function of f of x will basically f of x will have a vertical asymptote at x equals a, and as we remember, like as x approaches a, that's what we were referring to, the value that x approaches. If it follows basically a few things. So let's do this. Oh, well, we could just move this up. Basically, it will have a vertical asymptote at x equals a if the limit as x approaches a from the left side of f of x is equal to positive or negative infinity, the limit as x approaches a from the right side of f of x is equal to positive negative infinity, or if the limit, or if the general limit of f of x is equal to positive or negative infinity. And I know I said it has to follow these three criteria, but it could be any one of these. So basically, if the left-handed side of f of x is positive or negative infinity, or if the right side's limit is equal to the positive or negative infinity, or if the general limit is equal to positive or negative infinity, then the function f of x will have a vertical asymptote at x equal a, if any of the following limits exist. So basically, as we saw before, well, I mean, we could probably just do an example just to show one more time. Let's say we have a limit as x approaches 4 of 3 over x4 minus x to the third. Say we're given this limit. For the right-handed side, we could just say x is greater than 4. Remember, if it's the right-handed side, just denote that it's positive. So x must be greater than 4. We could turn that into 4 minus x is less than 0, which we can then change into 4 minus x to the third is less than 0. Oops. And we only really flipped them because um, we got x over to the right side. So that's kind of why we flipped it. And we're basically trying to get what we have in the denominator in our expression right here. So now we have 4 minus x cubed is less than 0. So think about it. Would we be given a positive or negative infinity value for this function? If we think about it, as x approaches 4, the denominator will approach negative infinity. Because since x is, well, from the right-hand side, x is greater than 4. So it would be 5 and 4.9, 4.5, 4.1, 4.01, 4.0001, as we saw from the table before. As x approaches 4, as x approaches 4 from the right-hand side, the denominator will approach negative infinity. Because we could tell from here, the more we do it, we also have a exponent here we have to consider. It becomes larger and larger, but it's still negative due to the fact that the exponent is an odd value. If it was squared, then our negatives would give us a positive. I don't know why I just put into, I don't know why I just did that, but our two negatives give us a positive if our exponent for the denominator is even. But since it's odd, it's going to be negative, and it's going to approach negative infinity if it's from the right-hand side. Because, well, our x is going to be a negative value, as we can see right here. And also, well, that means to the third, so it's still going to be negative. Now, let's take a look at the right-handed side. Or left-hand side, sorry. You could always remember the left and right hand side of a limit just by a graph. The left side on the x-plane is negative. On the right hand side, it's positive. So let's do the left side now. So basically we could write this out right here as x is less than 4. We could turn that into 4 minus x is greater than 0. And then we could just turn that into 4 minus x cubed is greater than 0. And now think about it. As x approaches 4, will we get a positive or negative infinity value? Well, if we do the same thing as we did before, which is just kind of think about it in our head and also use this right here, honestly, it's just kind of like common sense. We saw before, since it's a negative value, before it was a increasingly big negative value, since it was on the right-hand side. Now it's going to be less than 4. So since it's going to be less than 4, 4 is going to be the bigger value. It's always going to be 4 minus 3.99. This is like the biggest value could possibly go, but it's always going to be greater than the x value. And because of that, think about it. It's going to be 4 minus 2, 4 minus 3, 4 minus 3.5, 4 minus 3.9, 4. Like it's going to get increasingly, I guess, bigger. Yeah. So because it's gonna always be a positive number on the bottom, it's just bound to hit infinity. So to clarify, as x approaches 4 from the left side this time, the denominator becomes an increasingly small positive number, which creates infinity. And as we recall before, this limit from the left side is not equal to the limit from the right side. So, oh my god, I gotta stop doing that. So it's just the same as before. And we could just write out the graph real quick because we already know what we're gonna see because well the previous two examples were showed us the same thing. These two limits are on opposite sides, so to clarify our x is 3 over x minus or 4 minus x, sorry. 4 minus x to the third. And this is going to be our two one-sided limits. So it's going to be, it's going to show us right here, 4. And remember the asymptotic line, remember that rule, if it's infinity, if the left-hand side of the limit, this for this function right here, is negative infinity or positive infinity on either side, or for the general limit, then there will be an asymptote at x equals a, and a in this case is 4. So let's see our left side limits and our right side limits. This is going to be our left side limit, and this is going to be our right side limit. I know I'm not the best at drawing and writing, but this shows us our left side limit and our right side limit, and we see again that the general limit for this function does not exist. Again, however, that's not the point. The point of this is to illustrate the asymptotic line that occurs at x equals a when the left-sided limit or the right-sided limit or the general limit of this is equal to positive or negative infinity. If that's the case, then there's going to be an asymptote at x equals a, and a in this case being a equals 4. And we can see that right here with our function right here specifically. All right, now let's take a look at for our final example, let's take a look at some interesting limits. So we'll say the limit, because we're also going to be dealing with trigonometry as well, and these functions, trig functions. So let's see here. Well, we'll just say, oh my god, I am awful at writing. I'm illiterate. The limit of tan of x as x approaches pi over 2 from both the left side and the right side. We're going to be taking a look at that. But let's take a look at the graph in order to find the limit. So it's basically going to look like this. If you recall from, well, in general, this is tangent of x. And we see again with the asymptotes, right? We see here that there are two sides, right? There's a part of tan of x that's going to negative infinity, one that's going to positive infinity at different values, however. But if you know anything about trig functions, they kind of repeat, so they just kind of continue. And because of that, we see again at the same exact value of pi over 2, we will be given both a positive and negative infinity value. But we see again that it is asymptotic at x as a equals pi over 2, which is right here. As x approaches A, A is the since we'll just say since the limit equals to positive or negative infinity. Because all it really needs is either the left-hand side limit to be equal to positive or negative infinity, or the right-hand side. It could be either or it could be the general limit itself. That will lead to A being the asymptote. And we see that here as well. We could say as x approaches pi over 2 from the right-hand side, we could say that equals to infinity. Or rather, say x, we'll say negative infinity, sorry, because it's going down, right? Right-hand side, left-hand side, whatever. And from the left-hand side, it's going to be equal to positive infinity, as we see here, and as we see here. So this should help us better understand that when we are given a limit for a function, or we're asked to find the limit for a function as x approaches a, or a being pi over 2 this time, if that limit is positive or negative infinity, or the general limit is positive or negative infinity, then you're going to be given an asymptote at x equals a, even for a trig function like this. So it's universal. So yeah. So I hope you understood, or you guys all understood that it's pretty basic. It's not really like anything crazy. It's just explaining the idea of infinity in terms of limits. So yeah. So that will be it for today, and yeah.